tuning into the Light It Up podcast. On today's episode, Tom sits down with Mike Kachala, the Director of Engineering at Hinkley Lighting. Mike is one of the utmost experts in the LED industry. Mike also serves on UL's engineering subcommittee along with various other technical organizations. I'll let Tom pick it up from here. Mike, I want to welcome you to the Light It Up podcast. Mike Kachala is the Director of Engineering for Hinkley, probably one of the smartest guys that I know when it comes to talking about LEDs. He can easily get to the 60,000 foot level when I'm probably at 3,000 foot. So, Mike, welcome. I appreciate you taking the time out of your busy day with all this Corona stuff going on and all of that. So, Mike, tell us a little bit about yourself.
Sure. Well, as you said, that I'm the Director of Engineering at Hinkley. Been here almost 8.5 years now. And background, mechanical engineer, although I do a lot of different engineering disciplines, including electrical, a business major as well. Been involved with technology. I'm 30 plus years into my product development and sourcing and technology career. Got involved with LEDs well before we had white, the phosphors on blue LEDs making white. I had a business prior to being at Hinkley that I started about 25 years ago. Don't operate it now. But we got involved with LEDs early on in two places, transit, trains and so forth, where we're using ambers for wayfinding and safety and so forth, and also in panels and indicators and so forth, some of the predecessors to Dialight, who does most of that today. As such, we also were involved with Kodak and using LEDs and their monochromatic light properties to light darkrooms. Picking certain colors of LEDs that the emulsions were not sensitive to. So we would use sort of a near amber for mammography and a near green for black and white photography. And we lit Kodak darkrooms so that people could wayfind and be safe in the operations, which also let us get involved with the Lighting Research Center in adaptation. We actually were very early on flickering LEDs to help people transition from the daylight into the much more lower ambient darkroom environment. So white LEDs came along, and we actually set up a tent at the New York State Fair probably 12, 13 years ago, showing them off and seeing if there was a business in making products with white LEDs. And 5 booths down was NYSERDA, the New York State Energy Research Development Authority. And they were just asked by DOE to show some early LED at the fair as well, to see consumer acceptance and so forth. And we ended up in a very good relationship. And my firm developed the earliest forms of tape light, which we put on the flex circuit. Later, it went on to flexible printed circuit boards, and got involved with the earliest forms of white LED when we were talking about a device that would make 20 lumens for about $1.50. Today we're well under $1 for 1,000 lumens. Probably half $1 for 1,000 lumens in emitters. So, made a number of various devices for very special LED purposes, linear lighting and theatrical and early under cabinet and so forth. And then the light fixture companies started to get involved, and we're looking to somehow integrate LED into light fixtures. Hinkley was one of our larger customers, and as time progressed, Hinkley encouraged me to come on board, and so I closed up the business and hung my hat here. So that's what's more or less the background of how I got into it.
Okay. Well, you've answered a lot of my initial questions, and I wish I had a G-force suit on because we went from 3,000 feet to 60,000 feet in about a half a second.
Sorry about that.
So what areas do you oversee at Hinkley?
I am responsible for all the resources and efforts for everything that's product-based and technical. Obviously the engineering function reports to me is here, and also the commercialization part of Hinkley's product development. So the product designers, both internal and external, the factories, the product managers and all, they all come up to what fixtures they want to bring into production. And then my side of the house has to make that happen and bring it to volume.
And you take it all the way to the certification level, right?
We internally run our own test labs here at Hinkley. We're under Intertech Satellite Level 4 Ultimate, so we're autonomous for every aspect. So having that lab capability, the engineers are the ones who are the lab technicians. That gives us a chance to really understand what goes on in the fixture beyond just, hey, is it safe? And as a result, with LEDs, we've done an awful lot of testing and development and understanding, not only of integrated LED designs of ours and occasionally evaluating competitors, but we know a great deal about LED lamps as well.
All right. So I know a little bit about Hinkley and how you guys develop product, and I also know a lot about your competitors and how they develop product. And that's why I wanted to talk to you specifically about, a little bit about LEDs and how they are developed within fixtures and whatnot. So why do you think it's so important to take such a boots on the ground approach when developing LED products? And what I mean by that is, there's a lot of off the shelf stuff out there, and people will grab some type of a module that's available off the shelf and just slap it in their product and the way they go. You do things a little bit different. Why do you think it's so important to do it the way that you guys do?
Great question. Sometimes I can argue that we're smarter about things, and other times, because technology is what it is, we jump into stuff that doesn't prove out to be reliable for reasons we didn't understand. So Hinkley has a reputation of being first in the industry, but quite frankly, we've also had a couple of quality issues that have happened, and it's because of the nature of technology. But specific to why is integrated LED so different, we'll talk about lamps a little bit, but integrated LED is different because it's strapped down to the fixture. LED technology generates light extremely efficiently, far, far more than incandescent or fluorescent technologies, but it's a different set of physics. And as it generates light, it also creates heat, but the heat is of a format that has to go into a heat sink. And so there's a thermal integration, a thermal connection between the fixture and the LED. And because of that thermal connection, we have to step back when we're looking at a fixture design and wanting to make it integrated and follow more rules. The first one is to look at where do we want light to come out of the fixture? How much in what direction? And since LEDs are directional and lamps are just a great big glowing globe of light, when you go integrated, you have to place the LEDs where it makes sense. That puts the light where you want it. And then on the back side of the LED is where all the heat's coming out. So then you have to have metal behind the LED and have it get out to a place where it can be, as we say, shed, so that the LED runs cool enough that it has, good output and a longer life. And putting all those things together requires, from an engineering standpoint, more discipline, more knowledge. You have to know thermals, you have to know opticals, plus electrical, plus mechanical. So integrated LED design is definitely fixture-centric, at least by fixture type. And it's a challenge, but we've also been doing it long enough now that design has aligned itself with LED integrated. And luminaires have changed. Light fixtures don't look the same now with integrated LED because things can be stealthier, smaller. We can generate more lumens in a smaller space. So it's a marriage, and the industry has learned a lot. All of our competitors, including Hinkley, have absolutely learned a lot, and it's shaped how many people are in the industry. There's more people making light fixtures now than ever before.
Unbelievable. So what risks are there if somebody just buys an off-the-shelf module and throws it into their fixture?
The answer is going to be different in a few years than it is now, and it's certainly a little bit different than when it was a few years back. There was an awful lot of gear in the market available to light fixture manufacturers that was, advertised as being this module will do, all sorts of things. And the module was set up, if it was in open air, to be survivable, to have a decent life. When people started to put those into fixtures and cut off the airflow around the module, then all kinds of issues could happen. And then going back to the design of, since integrated LEDs are directional, and they require optics to make it, spherical like a lamp, the module may or may not have cast light in the right direction. So there were a number of modules that were used by some brands that generated lumens, but they didn't put lumens in the right space.
Right. So if I were to kind of summarize what I know and what you just said, correct me if I'm wrong in my assumption. If you have a light fixture that is integrated and it's designed well, meaning that the module, fits well within the fixture itself, it is heat sink or thermally conducted properly, that product should be able to produce a higher lumen product than one that is retrofit with a drop-in bulb.
Absolutely correct. The issue, though, is the legacy socketed fixture for incandescent, because of the thermal physics, may not be the ideal fixture for that module. Let me give you an example. The most clear one is ceiling mounted fixtures, surface ceiling, not recessed, not can lights, but surface ceiling fixtures that are
like
fully
Mounts.
enclosed. Like flush mounts, yeah.
Okay.
Yeah, flush mounts, yeah. And those fixtures are enclosed because obviously people don't want to have to get up there and clean them, bugs and dirt and what have you. And so done with incandescent lamps, they're all sealed up, fully enclosed, and they're wonderful for that aspect. And for incandescent, it's great because incandescent is more efficient the hotter it runs. And those fixtures are full of fiberglass insulation and foil, and the lenses are glass, and the metal's coated so that, you're not going to burn yourself touching it. And it's all designed for incandescent. All of that is 100% the improper thermal physics for an LED. Because the LED, we have to have a nice heat sink coming out and touching the air. I call it spread and shed. We have to have the right metal behind the LED to spread the heat away from the LED out to the outside air. And then the outside air has to have enough contact area to shed it, to take it away from everything so it runs cool. And so as people have seen in many of the stores and in newer designs of ceiling mount fixtures, they're a little bit different than the lamped versions for integrated. And they're actually thinner and in many cases smaller for the same amount of lumens. And that's what integrated LED design required. So just taking an existing fixture that may be in your home for the last 15, 20 years and going shopping for an LED insert to put in there may not give you the long-term result that you want. Duty cycle, meaning how long it's on, has a bearing. If we're talking about something that's on for only 15 or 20 minutes for various parts of the day, you'll have great luck. But if that fixture's on for hours and hours, most days, then you're not going to get the life that is advertised with the module. Right.
So it's really the fixture companies that invest in the technology, in the engineering with the right people, within their company that can put all of this together. That, in my mind, would produce the best quality of products.
Totally agree. I'll come back to the point that I said, a couple of years from now and so forth. As you know, Tom, because you live in this world too and deal with it every day, Eventually, the market and the developers get smart, and they figure out something that is more universal for everyone. And then the people that aesthetically design the fixtures get enough designs out there that the consumers start liking them, and then certain patterns set up. And this is not unusual. This is exactly what happened 100 years ago when people had to put glass and brass around light bulbs. The light bulb was the light bulb, and they had to figure out how to make the fixture work with the light bulb. So right now, the market is learning how to work with these modules. And with competition being what it is, there's less of folks like Hinkley that are out designing every little piece of the LED system. And more so, there are companies out there that are providing a total solution. We call it level 3, but that's another technical discussion. But those modules are coming forward in the market, and some have been, and Hinkley's been helping to develop those, not only for ourselves. Our strategy is actually to develop LED light sources that everyone can use, because it solves the maintenance issue, which everyone in the market's now realized with integrated, is that this stuff is unique to the manufacturer, and it's not available at the store. Some years out, 3 years out, 5 years out, 8 years out, when it fails and you need to change it, you don't want to throw out the fixture yet. You can't really get it except reaching back to the manufacturer, assuming they still have it. So the industry is starting to see the obligation that we create modules that become more standard, and then have them used by many pieces of the market. More brands use the same module, and that's what we've been working on for the last 2 years.
Right. So let's jump into failures. What are some of the either electrician caused or consumer caused failures when it comes to any type of LEDs?
Sure.
What do you think?
Sure. Most people who buy LEDs, integrated LEDs, have come to understand it's kind of like the older lighting technologies, fluorescent mill halide, that you have a light source and then you have electronics. Electronics being some kind of transformer, ballast, or today the word is driver. And all LEDs that run on AC voltage have some form of driver, whether the driver electronics are on the LED board, which is more common today, or it's a separate module that's also in the fixture. So with the electronics that come with it, which, by the way, incandescent light bulbs didn't have any of that. They just had a filament that grew hot. With electronics, there's, of course, different sensitivities to applications. And not all applications are the same. And any manufacturer who tries to come up with the driver/electronics that covers all applications ends up putting way too much cost into the product, and it just isn't competitive. So the nature that people have to have cost-effective product, which lighting is no different than anything else, says that different manufacturers have to target different applications. And so an LED system may not be usable in all applications. And that's really where the gist of most of the failures happen today. Years back, there were quality issues with the materials and consistencies. The manufacturers didn't really understand or test for the various limitations, or data didn't exist to prove out that the stuff was going to be reliable. If you talk to the professional people that do commercial lighting, they're going to tell you that they're still upset because fixtures generally are not living up to 5 or 10 year life claims, and that's going to be the case because of these things that cause problems. I know you're curious about what problems exist out there. Hinkley's got millions of light fixtures out in the field, so we've seen all sorts of failure modes. We've actually generated a list of 15 different things that fail a light fixture. 11 of them somehow are manageable or attributable to what Hinkley has done. 4 of them are attributable to what happens in the field. And the most predominant thing that happens in the field is fluctuation of voltage. Be it lightning strikes or other loads in the system. For example, an old building that has 100-year elevators, and if the electronics are not more up to date with managing the power for the elevators, if somehow the lighting near the elevator happens to be in the same power system, not necessarily the same breaker, but on the same same primary feed, the back feed from the motor's null can, stress the LEDs and take out the drivers. And what manufacturer can do things for that. Lightning obviously is the one that's a big one. And when it comes to big municipal stuff like streetlights and so forth, everybody has to put in lightning arresters. They're kind of like a one-time or maybe two-time fuse that's inside the pole, not in the LED luminaire, that will fail so that it doesn't fail the LED portion. The pole's still out, and they have to go out there and figure out what happened. And if it was a lightning-related issue, then they have to change the arrestor, the suppressor. But generally, the LED is okay. Not at all unlike what happens in landscape lighting as well, too.
Right. Yeah, it's there's just so many different things that can cause, and it's when somebody calls us up and they ask us about a failure of what's going on, we'll always ask, let me know the application. How old's the place? What's going on? And all of that. Because, it's the same type of thing. There's still people out there with knob and tube wiring, and all the issues that, that type of stuff causes.
Yeah, things like that happen all the time. And we're both manufacturers, and we both have a tendency to feel the same way. When we ask questions of people, they're thinking that we're looking for an excuse not to honor the warranty, when in fact we're trying to understand what happened with their install, what were the variables that maybe we didn't plan for in our design, so that we can learn and over time make better products.
Right. And I think that's real important. And a lot of times I'll start off the conversation with, I'm going to ask you a few questions, and it's not about us trying to get out of something, but I want to understand what's going on. And but you're right. You start talking about, what's this, what's that? What are you trying to get out of you? So yeah, I get it. So one of the main points that I wanted to discuss today was retrofits versus integrated, and we kind of talked a little bit about that. But one that keeps on coming up over and over again, especially when it gets to lamps, and is, the question people want to know about what wattage of LED lamps that they can put in their fixtures, or better yet, fully enclosed fixtures without causing problems.
Sure. No, that question's asked by consumers through our customer care organization multiple times a week. And it's asked more frequently by commercial specifiers who are looking for an easier to service situation, where certain fixtures have been for the last few years produced and integrated. The maintenance function is just not comfortable with having to uninstall a fixture or, be involved with a pair of wire cutters or what have you to change out an LED module that in this day and age, people still very much appreciate the wonderful Edison base invention of 100 plus years ago, that it's really easy to change the light source. So lamps definitely are, in our opinion, at least in decorative, resurging themselves. Costs have come down and so forth. But that question is asked fairly frequently. And unfortunately, there is no straightforward answer. It depends on the fixture. And the best that I can do is kind of answer it two different ways. For anybody out there that's in the commercial specification side, talk to your manufacturer of the luminaire who you're selecting and have them run the appropriate testing to tell you that the lamp that you're considering is good for the life of that fixture. If they have the abilities to do the testing for the safety of the fixture to get their marks, UL, ETL, whatever, they also have the capabilities to test for the lamps to make sure that they're doing the right things, especially in fully enclosed fixtures. But for the general public, let me try it this way, and hopefully this isn't at 60,000 feet. Maybe I'll get credit for having this down at a few thousand feet. But I want to call your attention to something that a number of us, especially up north, have, and that's a fireplace. And when we have fireplaces, they have this thing called the flue, which opens up the chimney so smoke can go up the chimney and not fill up the room. Well, the reason that works is heat causes air to rise. When you heat up air, it goes up. It goes opposite of gravity. Natural convection does not run sideways. It does not fall down. It only goes one direction, away from the ground. And an LED lamp, in fact, anything that generates heat, has the opportunity to create putting heat into the air. The technical term is called convection. And that's the shedding that we have to do when we put a LED bulb into a fixture. We have to spread or conduct the heat away from the LED. And in the case of a lamp, lamps being incandescent and shedding heat, what we call radiantly, neither conductive or convective. Incandescent lamps shed heat radiantly. There's ceramic sockets and glass and fiberglass and all that stuff meant to keep people from lighting their houses on fire, containing that radiant heat energy. So when we put an LED lamp into those fixtures, it's very much like opening up the flue on the chimney. If the fixture can allow hot air to escape upwards, you pretty much don't have to worry about the wattage of LED lamp that's going to be in that fixture. But if the fixture is going to stop the free airflow upwards, for example, an outdoor wall lantern that has a roof on it, and obviously you don't want rain to fall on the lamp in the socket, if that fixture happens to be glass heavily and maybe steel, it's going to be able to support less wattage of an LED bulb than, say, a fixture that may have a vented top and is less glass and maybe more cast aluminum. And that may support a much higher wattage lamp if needed. Another situation is a bath. People that have light fixtures above their mirrors know that, we as manufacturers like to show them with the light bulbs pointed towards the ceiling because that brings the best life to the fixture and to the lamp. But as folks get older, including me, we need to have more lumens, more light to see. And so a number of folks like to turn it so that the light bulb is facing down towards the counter. And if that light fixture doesn't have some kind of venting around the socket to let the heat get out, then that lamp is going to run a lot hotter and fail more frequently. Now, today with a 6 or 7 or 8 watt, 60 watt equivalent LED lamp in a medium base bath fixture, we're not talking about any significant loss of life of the bulb. If it's pointed up, that bulb will probably last 10 or more years. If it's pointed down, it might last 3 or 4 years. Certainly, the energy savings justifies buying the bulb and to do that. But when you get into things like those ceiling mount flush fixtures, again, where there is no air exchange, putting an LED bulb in them is just going to be a fast recipe for having to replace the bulb. And if you consider you have to get on a ladder and you got to get up there and take everything apart and get to the bulbs and change them, consumers, it's funny, you watch some of the endorsement / product reviews on the various websites, and people talk about buying bulbs and they show fixtures and how these bulbs don't work, and this brand is terrible, or I've tried 2 different kinds. They don't equate that back to the fixture. It's the few and far between that have found 5 or 6 bulbs that have failed of different types, and then eventually they say something to the fixture. That's the piece of learning that's not out there. And unfortunately, and folks can see I've published on this before, written some articles, that our government was more concerned about saving watts at the socket than being honest with you that LED bulbs can't really go into everything out there. There's a certain percentage of fixtures that they're better off not going in there. With that said, a fully enclosed fixture, a jelly jar or something that happens to be in a closet and it's turned on for 5 or 10 minutes and then it's off the rest of the day, that's not going to be an issue because the LED hasn't gotten hot enough, the driver hasn't gotten hot enough to fail yet.
So I think, there's 2 issues here. There's number one, there's a safety issue from a, UL standpoint, and then there's a bulb life issue. So what has what do the certifications say? What do the agencies say, UL or whomever, about I've got this enclosed fixture that's rated at 60 watts of incandescent.
Sure. I'm answering the question that you already know the answer to because we're on a lot of committees and so forth. But yet, we talk about this all the time because, if things fail, then we sell more of them. So, don't be too crazy about saying too much. On the flip side, we don't want people upset with things going on. The truth of the matter is, today, if you were to look at a lamp and the box is marked suitable for enclosed fixture, that is a rating, that is a statement that's governed by the Underwriters Laboratory standards. And Underwriters Laboratory is concerned with safety. They are not at all an authority that generates test standards and protocols and gives endorsements for durability, longevity, reliability, any of those things that people would expect with something that supposedly is great forever, 50,000 hours, whatever the number may be. So, is there an authority that does that? Well, yes, in the commercial space and in California, there were standards out there that did a lot of this kind of testing and caused manufacturers to do this so that, they qualified for the projects buying their products were qualifying for rebates and so forth that did have some life testing. The funny thing was the test standards that we had to meet gave us very generous environmental conditions to say that they passed when in fact people were using these light sources in fixture designs that were far more challenging. And as a result, the consumers' LED has been out long enough, have found enough failures, even though they've met those ratings and so forth, that they weren't real. They didn't get that experience life. I'm talking about people who use the light source for long hours at a time. Obviously, people that use the light source for shorter periods of time don't run into that. They don't have the hours applied to the source. But so that's led to, in general, this notion of LED is reliable as what people said, which then, again, is going back to, geez, we want to have more lamps because they're really easy to change than integrated in certain fixtures.
Right. So, getting back to the original question, can somebody with a 60-watt rated enclosed fixture, what size LED lamp can they put in it? They put a 5-watt, they put a 9-watt, whatever. It's a tough question to answer because every bulb is made a little bit different. Every bulb burns a little bit different. Is that base up? Is it base down? Or anything like that? The enclosed fixture standard, I believe, is somewhere around 225 cubic inches, the actual test fixture. So let's
and a lot of fixture designs out there are going to put a lamp in less than 100 cubic inches.
Absolutely. But they don't take into consideration and say like our 9.5 watt or our 4.5 watt, they'll put it in the same fixture. So if our 9.5 watt passes and our 4.5 watt passes, that doesn't give you any indication of what will work in a particular fixture. It is pretty much by size and all of that. And we get into it for some of our commercial customers where they'll send in their products, and we'll do our own testing and all of that. So from a safety standpoint, you're 100% correct. It's perfectly fine. From a longevity standpoint, you could take that bulb that's rated at 25,000 hours and cut it down to 5,000 hours just based on the enclosure that it's running in.
Tom, we've seen applications where lamps supposedly living for 25,000 hours and more were failing in less than 1,000 hours.
Yeah.
It totally depends. And getting a little higher, let's get up to 10,000 feet here, depending upon the electronics on the lamp and the construction of the lamp and how the lamp is set up to provide as much convective shed within the lamp as possible, Some lamps are better. We lamp manufacturers, good ones, certainly your firm is high on that list, have data for luminaire manufacturers, for fixture manufacturers to use to judge what wattage of LED belongs in that fixture, and can tell the end customer, you should expect a good long life out of this lamp based upon how it integrates to that fixture. And that process is the very same process to thermal tests that we have to do for safety to get our UL or ETL or TUV or whose ever mark. It's the very, very same thing. So it really falls back to the light fixture manufacturer working in conjunction with the lamp manufacturer, as Hinkley does very well with Emery Allen, to give that assurance to the end customer. But that's for someone considering buying a new fixture. For folks who have existing fixtures, it's going to be for a long period of time a catch as catch can. And really, if those customers, those folks out there who would like that advice, I can tell you that the lighting showrooms out there in the world have learned an awful lot. And if you happen to be fortunate enough to know commercial lighting people, neighbors, family members, church friends, whatever, chances are they know a bit more, because within the industry, obviously, we're getting smarter. They're just, no one of us, no one entity of us can create that communication to the masses. Quite frankly, the government to some degree is blocking that. And about me and my efforts to try to create something in mass communication. But there are some things, for a relatively short read that people could learn about where to put lamps and to max things out. I will say this, depending upon the size of the lamp, generally speaking, a medium base lamp, what we call the E26, but the medium base lamp, the average, A lamp, the pear-shaped lamp that everyone knows. For most fixtures, you really don't have to worry about an LED that's running at, say, 5, 6, 7 watts. It'll live much longer if it has an upward air shedding that can be done on the fixture. But at that wattage, that's not a problem. You start putting in a 15-watt lamp or an 18-watt lamp into some of those fixtures, and you're going to have problems with that lamp. It's not going to live as long. When it comes to the smaller stuff, the candle-sized bulbs and so forth, the E12s, and, of course, where Emery Allen is really, really strong with miniatures, the 2 to 3 watt level is really not an issue. And if you look at all of your miniatures, obviously you know that with your very good construction, that you're not exceeding those wattages. So in most places that you would put that lamp, that wattage is going to have a decent long life.
Right. So in 1598, is there anywhere that they say specifically what you can use LED as an incandescent replacement?
Wow, Tom, you just took us to about 100,000 feet setting a UL standard. So I'm not guilty for doing this alone. So to talk about the UL standard, 1598 is what generally applies to line voltage fixtures. The standard was originally written, obviously, for incandescent. Incandescent generates the most heat. Therefore, it has the most potential to start a fire. Within the incandescent standard, and we're talking about years and years ago, and it still applies today, depending upon the type of light fixture it is and the orientation of the glass and where the openings are and so forth, the standard allows any fixture to have so many watts of incandescent, so much of this size bulb, so many watts in total, and it falls into something we call general coverage. It doesn't require thermal testing. And there is no equivalent in the standard for how that maps to LED. I have had numerous conversations with UL about that, have even shared eons and eons of very good test data from our certified lab. But the fact is, LED lamps are not as consistent from manufacturer to manufacturer. There's so many choices in how you build a driver and how you put the lamp together that it's from a reliability standpoint, it's hard to predict. But by the sheer fact there's less watts in that LED bulb, probably only 10 or 15% of the original incandescent watts, UL's attitude, and I think you've been at some of the meetings where we've discussed this with UL, it's less watts, it's not generating the heat, so we're just as happy. They can stick the bulb in there, we don't care.
So, you just said that, UL is comfortable with. Have they written that down anywhere?
They don't need to. They don't need to, because it's not going to start a fire.
Okay. Well, the end consumer is looking for an answer. I've got a 60 watt. What can I use from an LED standpoint? Can I use a 5 watt? Do I have to go to a 4 watt and whatever? And so,
Tom, the whole reason that I agreed and we're doing this podcast is that there has to be more stronger appeal from consumers and so forth to want this, to get the powers to be to bend and to share some of that information, because we certainly can give some recommendations, sizes and so forth. But any one manufacturer just isn't there, doesn't have the ability, and doesn't want to create chaos doing it on their own. And I think you've been at some of the meetings where we discussed this directly with Energy Star. Directly with Energy Star. But certainly there's light manufacturers out there that definitely can give the consumers really good advice.
Right.
But for right now, if there's one thing anybody takes away from this podcast, is to think about that chimney and that flue. And if you're going to put an LED bulb into a fixture that's fully enclosed and is preventing the airflow from escaping at the top of the fixture, don't be surprised that the life isn't there. Right. That's just it in a nutshell.
Sure. Okay. Let's switch over and talk a little bit about integrated. Is there anything that can be done from a preventative maintenance standpoint on integrated fixtures?
Great question. And, there really isn't per se much that you can do. The one thing that comes up occasionally in commercial is if the luminaire is in an interior space and it's pointed upwards, dust collects on it, and therefore the lumen output decreases because the lens has got all this dust. So go up there and periodically dust it off. That helps maintain the light output. It doesn't really have a huge thing to do with the reliability of it and how often you have to manage the maintenance. But LEDs being electronic, there isn't much you do to maintain your TV or your smartphone or anything. So LEDs kind of fall into that.
Right. Yeah. So, from what you've seen on the market, in general, is there any way to replace a component on an integrated fixture if it goes out?
I can tell you that everything that we produce at Hinkley and have for the whole 8.5 years I've been here is 100% field serviceable. The question becomes two things. One, what's the desires, the wants of the person who has the fixture? Do they have the wherewithal, the comfort in dealing with it? And, do they have the basic hand tools? And that's really more of the barrier of being able to service something. We've talked ahead of time about some of this stuff, and, can you triage in the field? Is it the LED array that failed, or is it the driver? The answer to that question is yes. If you happen to have a $400 digital multimeter that has the correct RMS on it, and the manufacturer tells you what happens when the driver turns on, what voltages to expect, because it's not like a transformer that if it's not producing 24 volts, then it's not good, because that driver's got a lot of intelligence in it. It's got circuitry in it that's by UL standards and otherwise that protect things from going awry. So an average voltmeter is not going to tell you that. And then when it comes to the arrays and so forth, it's physical damage you're looking for. Have things cracked and yellowed, or have they charred? Does anything not look nearly factory fresh? And that's generally the best you're going to be able to do with the array. I can tell you in general, when a Hinkley customer has a problem with a fixture that has a separate array from driver, 100% of the time we're having them replace both.
Wow. Okay. So let's get into a little bit more specifics about possible failures, cause effects, and all of that. What happens if you put mixed loads on a circuit? Mixed loads, I'm talking about LED loads mixed with a CFL load, or mixed with a ceiling fan, or a bathroom exhaust fan.
Great question. And this is not as, light fixture manufacturers and lamp manufacturers really haven't either alone or as an association group committed to really studying this in depth and publishing technical standards and so forth. It's really, we've learned things as we've deployed the products and seen issues. And generally speaking, we find out more about this stuff in commercial. And let me give you an example of things that were surprising. As you know, when a commercial project is being built, the contractors have to have lighting. And lighting tends to get installed generally even before the paint or the finished carpentry is done. And depending upon how the contractors powered that room they're working in and where they're getting their power from, their circular saws or what have you, if the LED product doesn't have the proper protection, those contractor tools can actually damage the LED. Maybe not immediately, but, where the LED fails within, say, the first 6 months. So that's something that occasionally gets people in trouble. When you talk about mixed loads just in operation, part of the complexity of will this dim correctly or will my photo switch work correctly has to do with that particular sensor and or control and what it was designed for as far as load type. An incandescent load responds electrically, and I don't want to get into all the capacitive reactance, all that stuff conversation, but it responds differently than an LED load would. And LED loads are not at all the same, depending upon how they're doing the driver or the power. If it's dimmable, the type of dimmability it is, it will have a different amount of capacitance, which gets to the amount of inrush the system has and so forth. And all those things in combination with other things, especially compressors, anything that's a motor that has that has magnetism to consume and work with electricity and motion, those loads can mix together, and over time, maybe 6 months, maybe 2 years, 3 years out, puts extra stress on the electronics inside of the LED product, and those electronics then break down and get to a failure point. LEDs are fine; the electronics driving them is what fails.
Right.
The best advice is try to keep your stuff clean. In houses, residential situations, the older the house, as various people were making improvements, changes, whatever, from time to time, a particular breaker may have mixed loads where there's plug load and letting load on the same breaker. They're more likely to have problems with LED lighting. If it's a newer construction and everything is very clearly, one is with lighting load and the other is plug load, with the exception of, as you said, ceiling fans, although ceiling fan manufacturers have gotten smarter and smarter, and they're not dumping all of the power effects out back to the line. They're clamping it within the fans today, especially in the DC designs. That could have an issue. When you get into older commercial, and things like double tap neutrals and so forth, all kinds of things can happen because of mixed loads in the environment. Right,
and I think that's more of what I'm trying to address is a lot of the older retrofits versus the newer stuff. A lot of the newer stuff have taken into account, LED loads and this, that, and everything, but it's the old, the typical one that we get is person has one switch that turns on the bathroom exhaust fan and the light fixture at the same time. And the bathroom exhaust fan is, 15 or 20 years old, and it's got all of that going on. And then the other one is some of the very old ceiling fans, maybe 20, 25 years plus. They just did things a lot different back then that, we can go back and adjust, our technology to accommodate, product 5, maybe 10 years old, but much more than that, it gets to be a little bit more challenging. So,
sure. In your case, with your lamps, obviously the space of electronics is also an issue, and so there's only so much room to put in all the various protections that you might want to have. And then before we obviously talked about the cost, because the more electronics that are into it, the higher the cost. And also the more electronics something has, the less reliable it becomes.
In your opinion, do dimmers help with the life cycle of a LED product?
I have never found that a dimmer extends the life of an LED product, other than one might argue if the dimmer is always running and therefore the power to the LED is less, then the thermal load on the LED is less, and so therefore it could live a little longer. With that exception, dimmers bring the opportunity to hurt not the LED but the electronics, because depending upon not only the dimmer itself and the LED load, any connection of other loads prior to the dimmer control. Because in most homes, the dimmer is not the very first thing that's there since the circuit breaker. There's other things that are along that way. Those loads and their feedbacks and so forth can also impact. And as it goes through the dimmer control, things are not as designed for, in some cases, with filtering or protection of a driver. And so that kind of has its wear over time. And causes them to more prematurely fail.
Lutron's got a great tech services page on their website. They have published several white papers on dimming technology, whether it's low voltage or line voltage or anything like that. And I think somewhere that I read that just having a LED compatible dimmer, whether it's their at least expensive 153 brand or whatever, is better for the life of your LED product rather than just a toggle on-off switch. And it had something to do with the way that the power was introduced to the LED. It doesn't get slammed. It's more of a soft start. What do you think of that?
There's probably some truth to it. Lutron is a very tenured company when it comes to doing these electronics, but they're also, fairly close-vested. So we electrical people don't always get to know all the details. I can tell you this: in general, when you put a Lutron dimmer in place, immediately when that dimmer is in the circuit, the power going to the load is only 93% of what could have gone to that load, that fixture, had it only been a switch. So again, that's 7% less power. So the fixture is running a little bit cooler. So there's some help there.
Yeah, what's interesting about what you just said there is people will call us up and say, "Well, will your bulbs dim down to like 1%?" And it's like, it's not our bulb; it's the dimmer.
Right.
The dimmer's cut off before our bulbs will. So,
yeah. So to go further on the Lutron question, do they have some soft start capabilities, say in a CL control versus an old Triac, just straight up incandescent control? No doubt they've done that. I mean, certainly those things are put in place to cause LEDs to fail less, because obviously there's been enough time. Somebody buys a Lutron control and they put brand A LED in place and there's a premature failure. Then they put brand B in place and there's a premature failure. And then brand C, it doesn't take a rocket scientist to say, hey, could there be a problem with the control?
Right. Yeah. So we're running up close to an hour here, which is a little bit longer than we normally do. I've got some other questions that I have here that maybe we'll save to another time, regarding landscape lighting and inrush current and things like that. But let me throw something out at you. And I don't know if there's a quick answer to this or not. And that is the cause and effect of arc fault breakers and LEDs.
Yeah. Again, you and I have been to a number of meetings where this has been discussed, and it's an unknown box to many of us. Arc fault interrupt breakers are definitely a good thing, and the fact that NFPA, the National Fire Protection Agency, put them into the National Electric Code and so forth, is a good thing. And what people don't know is when there is some non-planned for load event, something consuming electricity on that circuit, that isn't the appliance, it isn't, the table lamp, it isn't the space heater, it isn't whatever. If it's a short, then certain signals backfeed in the wire, certain waveforms, electronics set up. And so arc flash detection at the circuit breaker by different manufacturers, was using software to look at what these waveforms were, and then throwing the breaker, to protect the premise from what could have been an arc flash. For those of you who don't know an arc flash is a process where the live and neutral conductor get together and furthest from the breaker, furthest from the utility, start to arc together, create a sustained arc that's really not an ignition source. It's just a destructive, messy, loud thing that travels all the way back to the circuit breaker and will stop when the two conductors are suitably far enough apart where they can't continue to do this. That's the fear. That's what happens. And it happens with old lamp cords that are laying on carpets that the vacuum cleaner runs over, too many times, or the cat steps on, or what have you, too often. And so having those in homes is a really good thing. So there are some breakers out there, without mentioning names, that had sensitivity to certain frequencies that some LED drivers had backfeed on. And it wasn't much if you had one light source on it. But when you started having 2 or 3 or 4 or 5 light sources, then you started to get these false trips. And, for us as manufacturers, it becomes a pointing game as to who's at fault for this. It's a good safety thing that came to the market. It protects us all. But then, it's not designed to comprehend, what's on the power line. And, it's fun to find the blame, and LEDs seem to be there. We didn't have a lot of that going on for Hinkley product. We had a couple cases earlier on, and they were all one manufacturer specific. And it's really been a non-issue for us since. But for other people with other driver approaches and so forth, they may still have problems. I'm just not aware of that.
Yeah. So anyway, it can be a problem. People have had problems with arc fault breakers failing or tripping prematurely. And you're right. It really, all the comments back to us is all geared towards basically one breaker manufacturer. So with that, I'm going to wrap things up. Is there anything else that you'd like to address in any of this, Mike?
No, I'm thrilled to have the opportunity. You're too kind with what you said about me. I just am another person in this world that wants to make sure that we do good things for society, not bad things. There's lots of ways for us to earn, revenue and to have our lives. And, you and I are very much 2 peas in the pod when it comes to, we have to do it correct. And, engineers, we have to learn a lot. And then we also have to share a lot. And a podcast like this gives us a chance to talk about things at all the various altitudes, as it were. Hopefully not everything was beyond 20,000 feet here today.
No, Mike, thanks again so much. I appreciate you taking the time out of your busy schedule. Hopefully everything gets back to normal here with all the corona stuff going on, and we can go about our lives here fairly quickly. So again, thanks, and I'll catch you on the other side.
Very good, Tom. We appreciate it, and you stay safe too.